Okay, so far so good on this new iPad Pro with my Apple Pencil. So again, a little messy, but we'll just make do. So I'm going to be working on A part A right now. So let's just sort of draw what's happening here. Catapult is positioned at the edge of a 350-meter cliff. It launches with an initial velocity 60 meters per second at an angle of 50 degrees at a height of 5 meters above the ground. Okay, so it's actually being launched from kind of like a little bit above the cliff right here. And the angle is 50 degrees. The initial velocity is 60 meters per second. The cliff itself is 350 meters plus an additional 5 for the catapult. And you can imagine down here, wee-hoo, there is a little unicorn. Blah, 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 blah. And it is 2,000 meters. So this position right here, let's call this 2,000 meters. And it is moving towards the cliff at a constant velocity of 7 meters per second. How long after initially spotting sparkles should a catapult fire? Okay. So you have to imagine that the catapult is going to launch something like this, but the unicorn is not quite in the right spot to be hit yet. So we have to basically wait for the unicorn to get into position, then we pull the trigger, and then we got to remember that this pathway, this catapult shot, the boulder, it doesn't instantly get here. It's going to fly through the air. So we sort of have to lead the unicorn. Any hunter out there knows what I'm talking about. You sort of have to lead the unicorn so that the unicorn and the boulder are in the same place at the same time, because the unicorn is not just going to sit there and wait to be hit. So first things first is let's, since we're interested in two objects when they meet, we should be using the distance formula for both and setting them equal to each other. So the first things first is let's figure out how long it takes for the catapult boulder to hit the ground, because we'll assume that that's where at least in the y direction, where the collision will take place. So first things first is got to get the x and the y components for this shot. The initial was 60 meters per second. If this is 50 degrees, and this is Vx and V initial Y. That means that Vx is equal to 60 cos 50, which is 60 cos 50, 38.57. So 38.57 meters per second. That's a 5. It's sloppy on my iPad. And the V initial Y is 60 sine 50. 45.96. Okay. So usually, again, the main idea is how long before this thing hits the ground, which is a y direction question. So dfy equals diy plus viyt plus 1/2 gt squared. And the final position will be 0. The initial position is going to be 355. It's going to be the 5 and the 350 together. So 355 plus, now the Vy, remember this formula has to be in the y direction, is going to be 45.96 t plus 1/2. Now this is a negative 9.8 t squared, because on my reference frame, positive goes up, negative goes down. You can tell the positive goes up because I said the y direction was initially positive. So that's how you can tell. So negative 4.9 t squared plus 45.96 t plus 355 equals 0. This is a quad. And I have a quad solver on my other iPad. So let me just crank this out real quick. 45.96 is my B value. 355 is my C. Okay. Again, I have two roots. Only one of them is positive because it only hits this height once. It's not like it ever comes back. So, of course, it makes sense that the only time we have is 14.41 seconds. Okay. So this thing will hit the ground in 14.41 seconds. But where in the x direction will this be? Remember that it's not like the catapult can be adjusted. We need to figure out exactly where this thing's going to hit. so that we can time when to pull the trigger so the unicorn is there. But we got to figure out in the y or x direction, where is this? So the range, or the dx of the catapult, is going to be vxt. So that's going to be, the vx is never going to change. It's going to be 38.57, and now the time is 14.41. So 38.57 times 14.41. I got 555.8. Okay. What this means is that at 555.8 meters, that's where we need to be. That's where the unicorn needs to be. Okay. So I'm going to redraw this a little bit, just down here, so you can conceptually get the idea. That if the boulder's going to hit right here at 555.8 meters, and the unicorn is somewhere over here, then when a unicorn is somewhere around here, let's say, then we pull the trigger, and this thing and the unicorn will hopefully be in the same spot at the same time. But this flight time is 14.41 seconds. So how far ahead does the unicorn have to be so that 14.41 seconds later, it's right there where it should be, right? So how far can the unicorn travel in 14.41 seconds while this boulder's in the air? Well, the unicorn's going at 7 meters per second. So dx equals 7 times 14.41. So 7 times 14.41, 100.87. Okay, what this means is that the unicorn, as soon as the boulder's flying through the air, the unicorn is going to travel 100.87 meters until the boulder hits the ground. So if this distance right here is 100.87, then where is this position right here where we need to fire? Well, that's going to be at 555.8 plus 100.87 for a grand total of 656.67. So 656.67 meters. Okay. When the unicorn is right here, that's when we fire. However, it's not currently there. It is way over here at 2,000 meters away. So when it's at 656.67, then we fire. Okay, so we got to wait this whole time right here. We got to wait for this time before we can fire. So how long do we have to wait? Well, if it's 2,000 meters away and we have to wait till it's at a position of 656.67, that means we have to wait for the unicorn to travel 1343.33 meters. Okay, so that distance right here is this. So we have to wait for the unicorn to travel all this distance so that it's here, so that we can fire, so that 14 seconds later, they're both right here, and kersplat, we kill it. So how long does it take for the unicorn to travel this? Well, it's just 134.3.33 equals 7 times t. That's just dx equals vxt. And so 191.9. So 191.9 seconds. That's how long we have to wait, but a little over 3 minutes, and then we can kill the unicorn, which is great because they're evil. Unicorns are always evil. So that is how we solve looks like number 2. There's only one part to it.